June 1943. The Pacific War was entering a new and deadly phase. Across thousands of miles of ocean, American fighter pilots were finally beginning to challenge Japan's once dominant air force. The arrival of the Lockheed P-38 Lightning had given the United States Army Air Forces something it desperately needed: a long-range fighter capable of escorting bombers deep into enemy territory. On paper, the P-38 looked nearly unstoppable. Twin engines, exceptional speed, heavy firepower concentrated in its nose, an impressive operational range. Many aviation experts believed it was one of the most advanced fighters ever built. Then the combat reports started arriving. Not reports about engines failing. Not reports about guns jamming. Something far stranger. Experienced pilots kept writing the same complaint: the airplane won't turn. At least, not when it mattered most. During training flights over the United States, the problem rarely appeared. But over the Pacific, during violent high-speed dives against the agile Mitsubishi A6M0, pilots discovered an alarming weakness. The faster the Lightning flew, the heavier its controls became. Some pilots described the sensation as trying to move a steel door with one hand. Others swore both arms weren't enough. Instead of responding instantly, the airplane seemed to resist its own pilot. Every second lost trying to force the controls meant another opportunity for a Japanese fighter to escape. Or worse. The complaints quickly reached Lockheed headquarters. At first, several senior officials dismissed them. Perhaps the pilots were exaggerating. Perhaps they simply needed more training. After all, the aircraft had performed beautifully during factory testing. Engineers reviewed the reports anyway. Every document repeated the same story: excellent airplane, wonderful engines, outstanding firepower, terrible control forces during high-speed maneuvering. One test pilot even wrote that the aircraft felt as though someone had welded the controls in place. The reports piled higher. Meanwhile, the men flying combat missions grew increasingly frustrated. Among them was Captain Robert "Buzz" Williams, a veteran with dozens of operational flights. He admired the P-38. He trusted its engines. He loved its firepower. But he hated one thing: the moment combat became truly fast. He remembered a mission over New Guinea only weeks earlier. A formation of American P-38s had intercepted Japanese bombers escorted by Zeros. Everything began perfectly. The Americans attacked from above. Several bombers immediately fell behind trailing smoke. Then the escort fighters reacted. 1-0 entered a steep diving turn. Williams followed instinctively. His Lightning accelerated beautifully. The distance closed rapidly. Victory seemed certain. Then he pulled the control wheel. Nothing. Well, not exactly nothing. The airplane responded, just painfully slowly. He pulled harder. The control column barely moved. His arms strained against the resistance. The Zero completed its turn effortlessly. Seconds later, it disappeared beneath the clouds. Williams never forgot that feeling. Not fear. Frustration. He knew exactly what the airplane needed to do. It simply refused to obey. Back at his airfield, the pilots gathered around maintenance crews, describing the problem again and again. One mechanic listened more carefully than most. Unlike many engineers working thousands of miles away in comfortable offices, these mechanics saw damaged aircraft every day. They spoke directly with the men risking their lives. One sergeant quietly asked a simple question: does it happen at low speed? No. Only when you're diving? Exactly. That answer stayed with him. Over the following days, maintenance crews inspected dozens of returning P-38s. Nothing appeared broken. No damaged cables, no bent control surfaces. Everything worked perfectly on the ground. Yet something clearly changed in the air. One evening, while studying the control linkage inside a partially disassembled Lightning, a mechanic noticed how much force the pilot had to transmit through the system. Every movement depended on cables, pulleys, and mechanical leverage. At ordinary speeds, no problem. At extremely high speeds, air pressure pushing against the ailerons increased dramatically. The pilot wasn't fighting faulty controls. He was fighting physics. The mechanic mentioned an unusual idea. What if we could help the pilot move the controls? Another crewman laughed. With what? A piece of wire? The hangar erupted in laughter. Someone joked that next they would fix engines with fence posts. Another suggested mailing the Japanese a note asking them to fly slower. The mechanic smiled but said nothing. Because ridiculous ideas sometimes become brilliant solutions. And within weeks, engineers from Lockheed would begin experimenting with a surprisingly simple modification that many initially dismissed as unnecessary. No larger than a man's arm. No complicated electronics. No revolutionary new engine. Just a clever change in how force traveled through the control system. It looked almost too simple to matter. But it was about to transform the P-38 into one of the most feared fighters of the Pacific War. By July 1943, the complaints from combat pilots could no longer be ignored. Every week, new reports reached the engineers at Lockheed Corporation. The stories came from New Guinea, the Solomon Islands, Australia. Wherever the Lockheed P-38 Lightning flew against Japanese fighters, the same problem appeared. The Lightning was fast, exceptionally fast. It climbed well. It carried devastating firepower concentrated in its nose. Its twin engines gave pilots confidence during long missions over the Pacific Ocean. But whenever combat entered a steep, high-speed dive, the airplane seemed to fight its own pilot. Some officers initially blamed inexperience. Perhaps younger pilots were pulling too hard. Perhaps they misunderstood the aircraft's limits. The veterans quickly disproved that theory. Men with hundreds of combat hours reported exactly the same behavior. One pilot summarized it perfectly. The airplane wants to keep flying straight. Unfortunately, the enemy doesn't. The engineering team led by Kelly Johnson understood they were facing something more complicated than a mechanical defect. Nothing was broken. Nothing had failed. Instead, the P-38 had become a victim of its own success. It was simply flying faster than many engineers had ever imagined when the aircraft had first been designed. As speed increased, the enormous pressure of the airflow pushed against the ailerons with incredible force. Those small control surfaces allowed the airplane to roll left and right. At ordinary speeds, the pilot could move them easily. At 400 miles per hour, it became another story entirely. The airflow effectively tried to lock the controls in place. The pilot wasn't merely moving cables. He was attempting to overpower several tons of aerodynamic pressure using only his own muscles. Even the strongest men struggled. One Lockheed engineer later described the problem in simple terms. Imagine trying to open a heavy door during a hurricane. The door still works. The wind just refuses to let you move it. That comparison finally convinced several skeptical officers. The airplane wasn't defective. Physics itself had become the enemy. The obvious solution seemed equally obvious. Install hydraulic assistance. Modern aircraft use hydraulic systems everywhere. But in 1943, nothing about such modifications was simple. Adding new equipment meant extra weight. Extra weight reduced performance. Every pound mattered in a fighter aircraft. The engineers needed something smaller, simpler, lighter. They gathered around design tables covered with blueprints. Hour after hour, they searched for ways to reduce the effort required to move the controls without redesigning the entire airplane. One proposal involved replacing major sections of the control linkage. Too expensive. Another suggested enlarging the control surfaces. That created entirely new aerodynamic problems. Nothing seemed practical. Then someone returned to an earlier idea. Instead of forcing the pilot to overpower the airflow, why not allow the airflow itself to help move the control surface? The room grew quiet. It sounded almost ridiculous. Using the wind. To fight the wind, one engineer sketched a tiny movable tab attached to the rear edge of the aileron. Connected through a simple mechanical linkage, the small tab would move first. The airflow striking the tab would then help push the larger aileron in the desired direction. The pilot would no longer fight the full aerodynamic load alone. It was an elegantly simple idea. So simple, in fact, that several people doubted it could possibly make much difference. One test engineer reportedly looked at the drawing and joked that it appeared to solve a major engineering problem with little more than cables and a tiny metal flap. Another laughed. "You're telling me this little thing is supposed to fix the whole airplane?" No one sounded convinced. But someone finally said the words every engineer hopes to hear. "Let's test it." Within days, technicians modified a test aircraft. Compared to redesigning an engine, the work seemed almost laughably small. A few adjustments, new linkages, carefully installed balance tabs. Nothing dramatic. Nothing that looked revolutionary. Certainly nothing capable of changing aerial combat. The first flight began cautiously. The test pilot climbed to altitude exactly as instructed. Everything felt normal. Engine temperatures remained stable. Control checks showed no unusual behavior. Then came the real test. The pilot pushed the nose downward. The Lightning accelerated rapidly. 300 miles per hour. 350. 400. Previously, this had been the moment when the controls became painfully heavy. Instead, the pilot gently moved the control wheel. The airplane rolled immediately. He blinked in surprise. He tried again. Another smooth response. Faster now. Another turn. Still responsive. When he landed, ground crews immediately surrounded the aircraft. Nobody needed to ask whether the experiment had worked. The smile on the pilot's face answered the question before he even climbed out. "It feels like a completely different airplane." The engineers remained cautious. One successful flight proved little. More testing followed. Different speeds, different altitudes, different pilots. The results remained remarkably consistent. The modification dramatically reduced the physical effort required to maneuver at high speed. The Lightning still couldn't outturn a Mitsubishi A6M0 in a slow horizontal circle. No one expected it to. That had never been its strength. Instead, the P-38 regained control in the very situations where American pilots wanted to fight. High-speed diving attacks, fast rolling maneuvers, aggressive hit-and-run tactics. Exactly the style of combat best suited to the Lightning's tremendous power. Word spread quickly through operational units. Replacement aircraft began arriving with the improved control system. Maintenance crews also received instructions for incorporating modifications into existing fighters whenever possible. Many pilots noticed the difference immediately. Captain Robert "Buzz" Williams certainly did. Only weeks after nearly losing a Japanese fighter because of frozen controls, he found himself chasing another Zero over New Guinea. The Japanese pilot repeated a familiar maneuver, a steep diving turn. Months earlier, Williams would have watched helplessly as the controls stiffened. This time, he rolled effortlessly into pursuit. The Lightning answered every movement almost instantly. The Zero pilot expected the American fighter to overshoot. Instead, the P-38 remained directly behind him. Williams later admitted he almost laughed inside the cockpit. For the first time, the airplane felt as though it was finally doing exactly what he had always believed it could do. The battle lasted less than a minute. The Japanese fighter never escaped. Across the Pacific, similar stories multiplied. Pilots reported that their confidence returned almost overnight. Not because the P-38 had suddenly become invincible, but because they finally trusted it during the most dangerous moments of combat. a tiny modification. One many people had initially dismissed, had quietly transformed one of America's most important fighters, and the Japanese were about to discover that the Lightning they thought they understood was no longer the same airplane. By the autumn of 1943, American fighter pilots in the Pacific began noticing something different. The Lockheed P-38 Lightning hadn't received larger engines. Its guns were the same. Its pilots hadn't suddenly become more experienced overnight. Yet something had changed. The aircraft now responded with a confidence it had lacked only months before. The small modification to the control system, combining revised linkages with servo tabs that used airflow to help move the ailerons, had dramatically reduced the control forces that had frustrated so many combat pilots. It wasn't glamorous, and it certainly wasn't the kind of engineering breakthrough that made newspaper headlines. Most people would never even notice it. But the men flying the airplane noticed immediately. And so did the Japanese. One of the first major tests came during escort missions over New Guinea. American bombers crossed hundreds of miles of hostile territory. Their greatest protection came from formations of P-38s flying above and behind them. The Japanese knew they couldn't allow those bombers to reach their targets. Fighter interceptions became increasingly common. On one such mission, Captain Robert "Buzz" Williams spotted several Mitsubishi A6M0 climbing toward the bomber formation. The Zeros approached exactly as intelligence officers expected. Fast, aggressive, confident. For nearly 2 years, Japanese pilots had developed enormous faith in their aircraft's maneuverability. Against slower, heavier fighters, the Zero often held a decisive advantage in low-speed turning combat. American pilots had learned the hard way not to accept those terms. Instead, they relied on altitude, speed, and surprise. Williams rolled his Lightning into a shallow dive. The twin Allison engines roared. Airspeed climbed rapidly. One Zero suddenly broke away, attempting to lure him into another steep descending turn. Months earlier, Williams probably would have watched him escape. Now, everything felt different. He banked sharply. The controls remained responsive, not effortless, but predictable. The airplane answered every movement without that terrible feeling of being locked in place. The Japanese pilot tightened his turn. Williams stayed with him. The distance between both aircraft continued shrinking. The Zero attempted another evasive maneuver. Again, the P-38 followed. The Lightning had never become more agile than the Japanese fighter in slow horizontal maneuvering. That wasn't the point. It no longer had to be. Its superior speed allowed American pilots to choose when to fight. The improved control response allowed them to stay in control during those high-speed attacks. Together, those advantages proved deadly. Williams fired a short burst. The concentrated battery of machine guns and cannon mounted in the Lightning's nose struck the Japanese aircraft almost instantly. Smoke poured from its engine. Seconds later, it disappeared beneath the jungle canopy. As Williams climbed back toward the bomber formation, he realized something remarkable. He hadn't once struggled against the airplane. His attention had remained focused entirely on the enemy, exactly where it belonged. Across the Pacific, similar reports poured into headquarters. Pilots repeatedly described the same improvement. The P-38 no longer seemed reluctant to maneuver during high-speed engagements. It finally behaved like the aircraft its designers had envisioned. Even maintenance crews noticed the difference. Before the modification, returning pilots often climbed from their cockpits rubbing sore shoulders and aching arms. Long missions involving repeated high-speed dives left many physically exhausted. Now those complaints almost disappeared. The improvement wasn't merely mechanical. It reduced pilot fatigue. And less fatigue meant better judgment, better shooting, better survival. The engineering team at Lockheed Corporation, led by Kelly Johnson, continued refining the aircraft throughout the war. The P-38 received numerous improvements. more reliable cooling systems, better cockpit heating for high-altitude operations, enhanced dive recovery features, improved reliability. Each modification addressed problems discovered only after thousands of combat hours. It demonstrated one of the great strengths of American wartime industry. Engineers didn't assume the first design was perfect. They listened. Pilots reported problems. Mechanics offered observations. Test pilots verified ideas. Factories implemented changes. Combat created better engineering. Better engineering saved lives. The Japanese, meanwhile, faced a different challenge. The Mitsubishi A6M0 remained a superb fighter in many respects. It was lightweight, exceptionally maneuverable. Its pilots were highly trained. But as the war continued, American aircraft became faster, tougher, and increasingly refined. The P-38 was no longer the awkward opponent many Japanese pilots had encountered during its early deployment. It had matured into one of the most formidable fighters in the Pacific. Its long range allowed missions no other American fighter could perform at the time. Its concentrated nose armament delivered devastating accuracy without the need to adjust for wing-mounted gun convergence. And now, its pilots could fully exploit those strengths. Perhaps the most famous demonstration of the Lightning's capabilities came on April 18, 1943, during Operation Vengeance. Flying hundreds of miles over open ocean, a formation of P-38s intercepted the aircraft carrying Isoroku Yamamoto, the architect of the attack on Pearl Harbor. Although that mission occurred before some of the later refinements were introduced fleet-wide, it perfectly illustrated the aircraft's greatest strength. No other American fighter possessed the combination of range, speed, and firepower necessary to accomplish such an operation. As the war progressed, improvements only increased its effectiveness. By 1944 and 1945, veteran P-38 pilots had developed tactics specifically designed to exploit every advantage. They rarely entered slow turning contests with Japanese fighters. Instead, they attacked from altitude, used speed to dictate the engagement, delivered devastating bursts of concentrated fire, then climbed away before the enemy could respond. It was disciplined fighting. Not spectacular, but highly effective. Years after the war, many aviation historians looked back at the countless technological breakthroughs that helped secure Allied victory. Radar, long-range bombers, aircraft carriers, the atomic bomb. Those inventions changed history. Yet countless veterans remembered something much smaller. A modest modification hidden inside the wing of a fighter airplane. A change so simple that many people initially dismissed it. It didn't require a revolutionary engine. It didn't demand an entirely new aircraft. It simply made an already excellent airplane easier for its pilot to control when it mattered most. Sometimes the greatest innovations aren't the most complicated. They're the ones that solve exactly the right problem. One mechanic's observation, one engineer's willingness to listen, one ridiculous idea that others laughed at. Together, they helped transform the P-38 Lightning from a fighter with frustrating limitations into one of the most respected aircraft of the Pacific War. The men who flew it rarely remembered the technical details. They didn't talk about aerodynamic loads or servo tabs. They remembered something much simpler. The first time they pulled the control wheel during a high-speed dive, and the airplane finally obeyed. That moment lasted only seconds. But for many American pilots, those few seconds meant the difference between watching a Zero disappear into the clouds or watching it fall toward the jungle below. Sometimes, history changes because of a famous general, sometimes because of a brilliant scientist, and sometimes because someone refused to ignore a problem that everyone else had learned to live with.